Welcome back to my channel. I'm Brian Kapke, and in this video we're continuing the subject of Microsoft Fabric, a new service being offered by Microsoft to solve your data analytics needs. In this video I want to get into the underlying concepts around Fabric so that you understand what it's trying to do and how to properly use it, how it was intended by Microsoft, and I want to answer the question, is Fabric a revolution or an evolution? And I'll talk about that as I go through the video. So where are we going? We'll start with what is Microsoft Fabric. Then we'll go into whether it is a revolution or evolution, and we'll talk about the architecture and background of Fabric. Then we'll get into more of the architecture and key concepts. So this video is really pivotal to getting your head around what Fabric is. Now in my last video I walked through the user interface and explained how to use it, but if you don't understand what it is and the whole point of it, then you're not going to get much out of that. So you need this video to kind of work with the previous video. Then we'll wrap up. So let's talk about what is Microsoft Fabric. Fabric is a browser-based UI or user interface extension of the Power BI user interface. And what I'm saying in there is Fabric has its own complete user interface, but it's integrated into the Power BI UI, which is already there. Fabric exposes mostly pre-existing tools, right, like Azure Data Factory, Power BI, Azure Synapse, and open source Apache Spark. So these are not all new tools, but they are presented with a new user interface around them and new integration features. It is focused on building solution using Azure Data Services. There's 2 points I want to make there. One is it is building on Azure Data Services. Generally speaking, although a lot of what you do will be using Apache Spark, which is open source, most of what you're going to be building on, things like Power BI or Azure Synapse or Azure Data Factory, are proprietary Azure Data Services. And when you build these solutions, the menus are called experiences or the experience menu. So you'll see like a data engineering experience. And it's the way the user interface is kind of laid out. That's kind of the starting point. And that's where you have like wizards or templates to start building an end-to-end solution. Fabric does add new features to simplify data sharing and governance. And these are not trivial. These are really game changers like OneLake, shortcuts that allow you to create like a little pointer to Azure Data Lake Storage, One Security, and everything is built on Delta Lake, which is the Apache Spark standard format for simulating relational database tables in Spark. So what is Microsoft Fabric's goal? Well, looking at what they're doing, the documentation, and what I've seen from using it, I'm going to give you what I think is the goal of Fabric. This is not official Microsoft dogma, but I'll tell you what I think. It enables end users, or it is a self-service tool, to easily create complete data-centric solutions. I don't want to limit it with AI or analytics. It's pretty much any kind of data-centric solution using Azure Data Services. All right, so it's really meant to be complete solutions you're creating. And when you do this sort of menu option, I mentioned this, I'll probably hop on this a lot because I found this a little tricky to get used to because you kind of weave between the experiences menus and then the individual object menus that you're working with. But experiences are where you create these end-to-end solutions, and there's wizards or some sort of template that guides you through the process to make it easier for end users to build their own solutions. So the takeaway I want to emphasize is it is not designed to be something where you have to go and hire senior consultants to do it. If you're setting it up for the first time, I think you do want to get some data architects and data engineers and technical people to help you go through the layers and architect the environment correctly. But once you have it set up, it should be something that the end users build their own solutions with very little help from others. That's kind of the whole goal. And I want to emphasize, it's not about the bits and pieces. When I first looked at Fabric, I'm like, oh, this is kind of cool. I could see using some of it for analysis, a little bit here and there. And while you can do that, you can say, I just want to add some analysis functionality to my Power BI development. You could do that. You could use the data lakehouse for that, or you could use building a Azure Synapse data warehouse. They have that in there, and you could use it to do queries and things. But that isn't really what Fabric is trying to get to. It's trying to get to comprehensive solutions, not bits and pieces. So where did Fabric come from? What's the history of this, Brian? Well, I'm going to take you on the Wayback Machine to a product we all know and love called SQL Server. SQL Server has been in the on-premises world for decades, right? And it actually originated from Sybase. SQL Server is a relational database engine like Oracle or Postgres that is very scalable, but only within a single machine. So what Microsoft decided to do at this time, this goes back a ways, Similar to what IBM did, they had a product called Netezza, and Microsoft came up with their own parallel data warehouse product. And what this did is it took an individual SQL server and expanded it to run SQL Server on multiple separate machines concurrently. It reminds me a lot of what Spark does, right? You got different machines running and you distribute the data in chunks called partitions. Very similarly, what happens here is multiple SQL Server instances are started up on multiple machines, and then the data is split up into pieces which are processed separately on different SQL Server instances, and then answers are brought together to give you your final result. So the idea is very similar to any scale-out solution, but it's all built on SQL Server. This product was called Parallel Data Warehouse, PDW. It was a physical appliance that companies would buy, bring it on-prem, install it, set it up, and then they could do this big data type of solutions. It, of course, wasn't terribly flexible. One thing I will point out here, though, is that as you'll see in Synapse later on in Azure Data Warehouse, because there was a split in how these products work. In other words, they actually, I believe, did a code-based split. They must have, because changes that happened in SQL Server, say 2012, 14, on, those changes did not automatically make it into Parallel Data Warehouse, nor did they make it into Azure Synapse, the later tool. So these are separate paths now. Once Microsoft set this up, a parallel platform is very different than a single machine working, and it poses challenges to any scaled out solution. You will notice that things like check constraints, which are just a default given on any relational database, often not implemented on stuff like Databricks or Snowflake, and for that matter, Parallel Data Warehouse. Companies are working to get those kinds of things implemented, but they pose a lot of challenges to Parallel Data Warehouse. So back to our story. After Parallel Data Warehouse came up, Azure became the rage, right? It was shortly after 2012 that Microsoft really started building out Azure and promoting it as the place to go for the cloud. So they migrated Parallel Data Warehouse to something called Azure SQL Data Warehouse, and that was called that until 2018. And I know I worked at Microsoft at that time, and we were promoting it, and it was a scaled out, kind of a competition to something like Spark, and it had the advantage of supporting T-SQL, which was a big plus. And a lot of people knew it. So Azure SQL Data Warehouse was essentially an evolution of Parallel Data Warehouse. As far as I can tell, it didn't change much between Parallel Data Warehouse to the cloud Azure SQL Data Warehouse. And this is where people could now create their own Azure SQL Data Warehouse databases using scaled out SQL servers, but it was limited, right? This is only a SQL-based database that scaled out. It did not offer a lot of additional functionality. So around 2018, Microsoft announced Azure Synapse. And Synapse, at its core, was built around Azure SQL Data Warehouse, this scaled-out SQL server, but it added a bunch of other things in it. The goal here was to allow people to build solutions and integrate various data services on Azure to do it. So this is an early diagram I found that shows you what Synapse looked like. When it was first introduced, most of this wasn't there, but by 2023, these are the pieces you could see. And just after this, Fabric was announced, and this is kind of really being relegated. I don't know if they're going to completely just kind of end it or what they'll do with this particular product, but this was, I think, really a more pre-Fabric thing. And I want to point out a few things here because you'll notice we have something at the top, Azure Data Factory, right? That's an existing tool, but the Synapse interface supported working with ADF pipelines. It also had something called ADF mapping data flows. Step one layer down, the storage bar here, and you see relational DB, right? DW. That is Azure Synapse, the scaled out SQL server. Next to that, you see ADLS Gen 2, right? So Gen 2 is a scaled out storage layer. And then you'll see Spark tables. And if you go below Spark tables, right, you'll see SQL on-demand pools. So you're already able to do Spark things. You could do Spark pools basically. And you see right next to Apache Spark pools. So you're able to do scaled out work with open source Apache Spark interoperating with SQL Server scaled out. And then you see some other things, Azure Synapse Studio, monitoring, management, security. And then at the very bottom, this was all designed to work really well with Power BI, which even back when this was created was an important product to Microsoft. It was already exploding in its popularity. What I'm trying to point out here is that this was the foundation of Fabric, and it had a lot of the same goals as Fabric does. Allow self-service construction of solutions by non-technical people. That was really the goal here. So Fabric came along and wants to take this way further. And this is just pointing out that the relational DB here is Azure Data Warehouse. So let's look at the Fabric architecture. On the left side, we have Apache Spark. And remember, this was also part of Azure Synapse. But Apache Spark now has center stage. It is the core of Fabric. You can build lakehouses with it. And in fact, the underlying storage is a standard, as we'll see, for Apache Spark. So we're using Apache Spark. This is open source Apache Spark. It supports Data Lake, which is any kind of format you can pretty much think of, as well as Data Lakehouse. Data Lakehouse is the ability to support data warehouse star schema type of functionality on Apache Spark, and it uses something called Delta tables to do it. Up until this point, and this is a relatively new thing still, but before Delta came along, all you could really do was extract data and write out more files, but you couldn't insert, update, and delete to the data, and that was a real limitation. And you may remember just a few years ago, everybody was crying the end of the data warehouse, no more of that work. Well, it's come back with a vengeance. People need curated data. They need to go back to the star schema. So all that hype about getting rid of the data warehouse was way too soon. And Delta tables is the answer to do that. The idea of Data Lakehouse is in fact a construction in which you get lake, like data lake, but also data warehouse, hence Data Lakehouse. You also have all these tools, right? Python using PySpark, R, Scala, and Spark SQL. I do want to point out though, even though you can simulate relational database tables using Delta, they are not really truly relational database tables. They're using Parquet files underneath and a very interesting kind of like source code control, almost logging approach to the files underneath, so that it looks like you're able to do insert, updates, and deletes, but it's not exactly doing that. And I will put a link in the description for a riveting video I did understanding how Delta tables actually work. But that's at the core of Fabric, is you're going to build lakehouses using Apache Spark within Fabric. Now, how are you going to build them, Brian? How do I do this? Well, one of the main tools you can use to build your lakehouse and curate your data and extract, transform, whatever you need to do, build machine learning models, is notebooks. Now, these are not really standard Jupyter notebooks. People may make that mistake. There's some differences. Namely, you get visualization right within it. You can create plots and everything without writing code to do it. So it has some functionality that is in addition to what you might see in Jupyter. In HT Insight, I believe they call them Livy notebooks, and you could see references in HT Insight. I did some videos that involve some of those, but they look a lot like Zeppelin notebooks. I don't know if Zeppelin and Livy notebooks are really the same. Not really sure exactly, but they're pretty powerful notebooks. That's the one takeaway. So if you've used Databricks notebooks, you're going to feel at home using the Fabric notebooks provided for Spark. You also have something called Spark Jobs to run different types of tasks. I'm going to come back to this point, but Spark jobs, the way Fabric defines them, is think of it more like SQL agent jobs or tasks you want to execute. So I'll equate it to like cron jobs, or I've used the Windows task scheduler, but think in those terms, except it's related to Spark. You want to run maybe a Python script or some SQL code. You can do that using the Spark jobs that are available in Fabric. Those are not part of open source Spark. Those are something that is additional given to you as part of Fabric. Can support reading and writing of many formats. Well, that's just what Spark does, right? Spark can pretty much read and write anything you can think about, and so that's supported here. And when you're doing AI, Spark has something called Spark ML, which is lots of different machine learning models that you can use right out of the bat with Spark. It also supports many other open source frameworks that you can bring in and leverage to build your machine learning models. But it also comes with the ability to use custom Microsoft ML models for AI. And all underneath this, and this is a key game changer, difference between Synapse coming to Fabric, which is Delta Lake. Delta Lake is the standard now for read and write, insert, update, delete, your CRUD operations, simulating SQL-like tables on Apache Spark. It's the standard they came up with, and Microsoft has adopted this across the board within Fabric to store data. You can store in other formats, just like flat files and things, but when you want to create data warehouses, updatable data, then you'd use Delta Lake. Typically, you'll also use the open source Apache Spark for your data science, AI, machine learning model training, yada, yada, yada. So if you're doing data science, Spark is really good at that, right? You have Spark ML, and you also have the custom models I mentioned, but you have a lot of open source frameworks and many things you might want to use with that. My guess is most people will stick with Spark when they're doing their machine learning model training, and the notebooks support that, and it works with a ML ops engine called ML Flow. So you get a lot of really cool features here, and it will work with Azure ML as well. So something you wouldn't see in the open source world typically is Power BI and its tabular model. In Fabric, the tabular model is called the semantic model, but just kind of in your mind, replace that with the tabular model. You have to have a tabular model to do any kind of querying and analysis in Power BI. In other words, when it reads data, it has to load it into, one way or another, the semantic model. Within Fabric, you automatically get a semantic model to read your data lakehouse. An interesting thing that you also get is a view built on Azure SQL Data Warehouse, right? Azure Synapse. T-SQL is the engine underneath it. So it is a scaled out SQL Server engine that allows you to query your open source Delta Lake, so the Delta Lake you created with Apache Spark, you can use the SQL Analytics endpoint to do queries against it. And I put read only because you can't update and insert and do things against the tables when you're using the SQL Analytics endpoint. It is using T-SQL. So the one thing I want to make sure you don't get tricked like I did is when you see in Fabric the SQL Analytics endpoint, this is not the same as a SQL endpoint in Databricks. In Databricks, a SQL endpoint is just Spark SQL, a Spark SQL distributed cluster for you to work with. This is not that. This is actually under the covers, apparently somewhere creating a scaled out SQL Server environment. So multiple nodes to work on it and allowing you to do queries through it. And it's automatically there. I haven't seen any delays using it, so it just seems to automatically be available. The biggest difference between this and say Spark SQL is you're not using Spark SQL syntax, you're using T-SQL. Something you can use if you want to, but you don't have to. Underneath the Fabric architecture, and I emphasize this a lot, is you're trying to build end-to-end solutions, which are called task flows. So that's where you'd create your kind of ingest data, clean it up, do maybe your medallion architecture, right? Bronze, silver, gold. Your gold would be the final curated part that Power BI might use, and you might even use it for other things like model training. So we have all this here, and so far all we've really looked at is primarily Apache Spark with some extra Microsoft specific things thrown in, especially the semantic model and the SQL Analytics endpoint. However, you also have something that Fabric talks quite a bit about, and it can be a little confusing, it was for me, is the Azure Synapse Warehouse. This is the scaled out SQL Server engine I talked about earlier. It supports T-SQL. It really is like a SQL Server database, except it's split somewhere in the code base, I believe. But you do have functions and stored procedures which are stored in the database. Now I want to be very careful here because Lakehouse is in fact a warehouse. And I get a little confused here because they're saying you built a lakehouse and you can create a warehouse. When Fabric says a warehouse, they specifically are referring to Azure Synapse Warehouse, not Delta Lake, which is also a warehouse, right? You can build a star schema using Delta tables and you have a warehouse. That's why they call it a lakehouse. But when Fabric talks about this, what they really mean is you're building an Azure Synapse Warehouse. Can I still do it the other way using just Delta tables? Yeah, you can. I don't think there's any reason you couldn't. But be aware when you're reading the documentation, the menu, and it says, work with a warehouse, they're really talking about an Azure Synapse Warehouse. Now, the important thing to understand here is you already have a SQL Analytics endpoint on the left, right? You didn't even have to create a Synapse Warehouse. The difference when you create, and this has to be explicitly done, you don't automatically get one, you have to explicitly create an Azure Synapse Warehouse if you want one, and the point of that is that you can update the data through the warehouse. So you can use T-SQL and functions and store procedures to update the data in your Delta tables. If it's not an Azure Synapse Warehouse, then you can't update data there. So let me talk a little bit more about that. So the Azure Synapse Warehouse supports SQL Server Management Studio, which is an awesome tool to interface with databases. It also supports Azure Data Studio. Synapse Warehouse is primarily used for your gold layer. At least what I've read in the documentation, what Microsoft seems to be recommending is do all your grinding away, extract, summarize, clean up, get your data curated. And when you're ready to push out your final clean curated data to be used in reports, in other words, the gold layer, then you would write it out to the Azure Synapse Warehouse. So I do want to be a little careful here too. Since you are doing your crunching, right? You're doing your CRUD operations, create, update, delete. You're extracting and building bronze, silver, gold. The bronze and silver are actually doing updates and things using Delta tables, and you are essentially getting a pre-warehouse, but the Fabric documentation's considering the warehouse to be your gold layer. So let me talk a little bit about Fabric concepts. First one I want to talk about is the Fabric workspace. This is one of the first things you will need to create just to get started. So you can see here from my own example what I did in my last video. I created a lakehouse. So a workspace is like a folder or a container that will hold things that you're creating as part of your solution. It sets the boundaries for contained objects. And you can use this container as a way to secure access, right? You can say these people have access to this workspace, these people don't. So it is a boundary for security. And you can group objects such as those used for a specific solution. In fact, generally I would say your best bet is when you have a new solution, in other words, a complete solution end to end, you're going to ingest data, extract and create things and clean up the data and finally curate it to say your gold, maybe create some ML models off of it, do some reporting. That end to end will be its own solution in most cases, and I would say it should be in its own workspace. It's a lot easier to manage it. You'll know what belongs to your solution. So that's a good way to kind of think of a workspace. But if you're also just maybe not quite so formal, you want to be able to share a lot of queries and reports and things you're doing with a team, you might create a workspace for that purpose as well and just call it like, sales analysis or something, and then share that with other people. As I said, this is typically the first thing you're going to create when you're creating a Fabric solution. So I mentioned Fabric experiences, and if you look on the left-hand side under the word Synapse, you see data engineering, data science, and data warehouse, and I added these gold squares next to it to sort of translate what that is. Data engineering is Apache Spark. That's when you're working with Apache Spark. Data science is building your AI solutions into a model training, and data warehouse is specifically Azure Synapse. It does not mean Lakehouse, it is Synapse. Experiences are meant to be kind of like jump starts, think of like wizards and templates to get you going building end-to-end solutions. A couple of things I want to point out here is new things that you have is Data Activator and Real-Time Intelligence. Real-Time Intelligence is really Event Hub under the covers, but Data Activator is a new feature which I think is pretty cool. It allows you to filter the streaming data coming in and then take actions on what you find. So you might be, streaming different types of activity, and suddenly you see something that's a critical thing that happened in the business, like maybe you're streaming police data and everything's coming in, but suddenly something comes in that's a critical emergency crisis that requires immediate attention. In one client I worked with, I thought a great opportunity for this was recalls. When products get recalled, many times maybe not that critical. There's something, a string comes loose and people don't like it, or there's a product recall. But if it's product safety, imagine a toy which has a choking hazard, then you want to recall that immediately. You could use the Data Activator to trap that and immediately say notify somebody, text them, whatever it is, immediately process that activity. So Data Activators are really interesting, and I'll be interested to see where it goes and how people use it. Industry Solutions is an interesting thing. It's a jumpstart to business-specific end-to-end solutions. What do I mean by that? Well, I mean, two that they have ready right now is sustainability and retail, but I think down the road it might be like retail banking applications, maybe, utility companies like gas conservation analysis type solutions, healthcare outcomes. All these things are going to eventually, I think, go into this sort of gallery so that customers can kind of get a jump start on what they want to do and maybe pull it in, play with it, use it to learn, but also then maybe tweak it and adjust it to their needs. They'll be able to build a solution faster. This gets back to our question, evolution or revolution? What do you think? Is Fabric an evolutionary product or a revolutionary product? Well, I think it is an evolution of Azure Synapse, and that's not a bad thing. Fabric is a user interface over mostly existing services plus some powerful new concepts. But you can leverage existing knowledge, and that's really important. So if you already knew how to use Synapse really well, you're going to be very well positioned to jump into Fabric. But if you already know how to use the tools that Fabric's using, you're also going to be in a good position to jump in and start using Fabric. So that's why I think evolution is better than revolution. You can jump right in and start using Power BI. If you already know how to use Azure Data Factory, you're good to go. You know how to use SQL Server, then you can use the data engineering warehouses, right? The Synapse warehouses. You can use Apache Spark. So if you already know how to use Apache Spark, you can jump in and be productive right away. I'm going to make one more point about this user interface issue I had, which is getting my head around what is an experience versus objects. My first creation of an experience, I went in and said, I want to do the medallion architecture like you see here. And you can see it created this sort of template with all these little boxes, and I could now go in and plug in code or objects to execute to do those steps. So in this case, it didn't build it all for me, but it gave me a mapping. Like you can see the bronze data, right? In that second square, I would plug in some sort of code. It could be like a Spark notebook to bring the data in and create the bronze layer. Notice on the left side, there's a lot of different possible services it may use to support this architecture for this end-to-end solution. So the experience is meant to, as you can see here, create an end-to-end solution. It's going all the way from the ingestion of the data, bronze, processing, silver, further transform, golden data, right? That might be Azure Synapse Data Warehouse, and then visualizing the data and serving ML models if you created them. And you can use many different services on the left. Now bear in mind, you will be paying for those services, but they will fall under Fabric capacities. And I plan to talk about Fabric capacities in a future video, but the idea behind Fabric is instead of worrying about every little individual charge that you might get when you're in Azure, the Fabric umbrella will absorb it. You say like t-shirt sizing, what level of capacity you want, and whatever you're doing should fall within that capacity. It will just be contained in there. If you find you're starting to exceed what it can support, you may have to upgrade your capacity, but it's like t-shirt sizing as I mentioned. So you can see we have the services, and then we have these different objects, right? So the experiences is this end-to-end solution, and you're building it. But you've got to work with individual objects to do that. I need to create, for instance, a pipeline perhaps, or maybe I'm going to create a notebook and plug it into my bronze task there. So when I'm creating these various objects, as you can see here, a subset of some of them, whether it's a data pipeline, an ML model, event stream, those are different tasks within the overall experience or solution. And the main takeaway here is that when you open them, the entire user interface will shift and be custom to that particular object. So if you go from an experience and then open a notebook, you'll notice the entire user interface changes, and now you're just working with a notebook. It can be a little tricky to figure out where you got. This is where I get a little confused, like, okay, why did it change and where am I? Because it's not always clear that I'm in a warehouse, or I'm in a data lake, or I'm in a lake house. So I found it a little tricky, but on the left side, and I pointed this out last time when I did the video, and I'll leave a link in the description for that, but it was a prior video to this one. And in that one, when you do different things, you'll see a little box get created on the left, like a little taskbar, and you can click on that to get back to where you were, different objects and placeholders. Okay, it's going to be a little bit of a walk here, but Fabric did something in its documentation and the concepts which makes it a bit challenging to get your head around, because in many cases they took existing pretty well-known terms and then used it a different way. So that causes a little confusion. They didn't say let's create a whole new word. And the first one I want to get to is lakehouse. Lakehouse is pretty well understood. I'm going to jump to the right here, standard meaning. Lakehouse is typically delta tables usually defined to relate to each other in a star schema, and a data warehouse on Spark is called a lakehouse because you also of course can store many other types of files, data lake, but it's also a warehouse, so a lakehouse. But when you're speaking of this in Fabric, it adds a few other things. So under the middle column, Fabric meaning, a set of related objects, which includes a data lake, yes, but also delta tables, a Power BI tabular model, semantic model, and an Azure Synapse database view of the delta tables. So those last two things are specific to Microsoft and Azure and would not normally be considered part of a standard open source lakehouse. Data warehouse. As I mentioned before, when you say data warehouse, it's not really specific to a platform, but when you're speaking about it on a lakehouse, it's implied. So a lakehouse, you can see standard meaning on the right, is basically a Spark data warehouse. It allows insert, update, delete. When you speak about it on Fabric though, the term specifically means an Azure Synapse database of the delta table stored. I put view. When using the SQL Analytics view, it's a view, but if you're creating a data warehouse, you're actually creating a completely separate copy of data to be held in your Synapse warehouse, but it will store it in delta format. The semantic model. This is a Power BI tabular model. Standard meaning when I hear the word semantic model is just a star schema. SQL Analytics endpoint. As I mentioned before, when you're in a read-only mode, then you're using the sort of data warehouse view, the Azure Synapse database view of your delta tables. And that's what the SQL Analytics endpoint does. But when you actually create a data warehouse, typically for your gold layer, you're going to copy and store your data there. It's not meant to be just something you query and look at your lakehouse from. In fact, it's separate from your lakehouse. So in standard meaning would be a Databricks SQL endpoint is a service that supports Spark SQL queries. That's where I was getting confused because I'm used to a Databricks SQL endpoint. But in this case, the SQL Analytics endpoint is a Synapse view of your data. Synapse data engineering. Ironically, they use the word Synapse, but it's referring to open source Apache Spark tools. So on the right hand side, the standard meaning, when you say Synapse data engineering, what I would expect you to mean is this is like Synapse specific stuff. It's not open source Spark. So that throws me a little because you're saying Synapse in it, but you don't really mean Synapse, you mean Apache Spark. Data flows, and then they put in parentheses Gen 2. This is really just Power Query, and it's enabled so that you can use Power Query to do part of your ETL processing. Spark jobs. This is confusing because when they talk about Spark jobs, they're referring to essentially a job execution that you control, like it's setting something up to run on a schedule, maybe a Python program or some Spark SQL. But when you talk about Spark jobs in open source Spark, it means a specific thing. It's already used as a term. Whenever you run anything on Apache Spark, it has to kick it off, do the analysis, and then execute your code. That is called a Spark job, and you go into the Spark UI to look at it. So try not to get too confused on that. Sorry, I kind of fell behind in my check marks, but try not to get confused on that, especially if you go into an interview. A Spark job in Fabric is not the same as a Spark job in Spark. The same word being used twice, so a little confusing. Real-time analytics just means you're using Event Hub in Azure, so you're streaming. Now, what they typically also add with this is something called Custo database or Custo database query language, so KQL, but generally real-time analytics is general streaming concept. So specifically real-time analytics here means Event Hub and Custo. Custo query language is a proprietary query language to be used with Event Hub data streams, and you can create a Custo database to hold that streaming data to be queried. All right, that was a lot, I know. I hope this was helpful. I think there's a lot of concepts here. I recommend you kind of go back and think about those. I'll put links in the description to my prior videos so you can go back to that, but it should be the first video in this playlist. I'll also put a link in the description to when I did an analysis of Delta tables and the Delta logs in particular, so that you'll get an idea of what Delta files really are all about. So what is Microsoft Fabric? We talked about this. It's a online browser-based user interface that is within the Power BI user interface that allows you to build end-to-end self-service data-centric solutions. Is it a revolution or evolution? I looked at this closely and I think it is an evolution of Azure Synapse, but with significant improvements and changes, and Microsoft is certainly getting behind it. So I think it's going to be a potential game changer here. I also talked about architecture and key concepts, and a big part of this was, kind of the experience versus the objects. Look at the terminology and make sure you can sort out like the sort of reuse of common terms that Microsoft redefined to mean something else, because it's a little confusing and that can make learning Fabric, I think, that much more complicated. All right, well, thank you for watching. Please like, share, subscribe. And until next time, I'm Paul and Fire. We're all in this together. Thank you.